Let's take a look at exercise 13 from section 8.2. We want to find the inverse of this matrix. So we set up a matrix that has on the left side the 3 rows of our matrix. We put a vertical bar after that, and then we write the 3 by 3 identity matrix. And we are going to row reduce this matrix until the identity matrix is on the left, if that is at all possible. Alright, so we want zeros in column 1. So we're going to leave column 1, row 1 unchanged, and we are going to change row 2 and row 3 so that we get zeros in column 1, in row 2 and row 3. And one of the things you can do is you can circle where you're trying to get your zeros if you find that helpful. So when I change my row 2 by adding the previous row 1 and row 2 together, I get the row 2 that you see. When I change row 3 by adding the previous row 1 and row 3 together, I get this new row 3. So I'm actually going to write what I've done here beside. Typically that's where you write it. So I'm going to write what I've done beside the work that I've done. So here's how I got this new row 2. I added the previous row 1 and row 2, and I got my new row 3 by adding the previous row 1 and row 3. Now notice that row 2 is exactly the way I really want my row 3 to be. So I am going to interchange row 2 and row 3. So I'm going to leave row 1 as it is, and I'm going to interchange row 2 and row 3. And this really makes my work easy because now my row 3 is complete. Row 3 is exactly as I want it to be. So what I need to do now is I need to get my zeros in column 2. So I'm going to change row 1 by adding row 2 to minus 5 times row 1 in the previous matrix. I'm getting the zeros I want in column 2. So it's row 1 and row 3 that I'm going to change. So kind of notice that pattern. Row 2 is not going to change as I work to get my zeros in column 2. And notice those zeros are going to be in column 2, rows 1 and rows 3. And so if I add row 2, so notice row 2 is the row I'm not changing, and I'm going to add that to negative 5 times row 1. So everything in row 1 is multiplied by negative 5 and then added to the entries in row 2. And I'm actually not going to change row 3. A lot of times you would be changing row 3 to get that 0 in column 2 of row 3, but we already have our 0 there. And notice that I get my zeros first. In order to avoid fractional expressions, I get my zeros first, and then I get the 1. So I have all the zeros that I want, except in column 3, I want a 0 where that 10 is in row 2. So I'm going to I went ahead and changed row 1 by multiplying it by negative 1/5. And I'm going to change row 2, and I'm going to get the 0 that I need in column 3 there. All the other rows have the zeros where I need them, so I can then get the 1s. So I'm going to do negative 10 times row 3 plus row 2 of the previous matrix. And that allows me to get the 0 in row 2, column 3 that I need. And so now I have all the zeros. Row 1 and row 3 are actually just as I want them. Now I'll get the 1s. I've already got the ones that I want in row 3 and row 1, but I have to multiply the previous row 2 by 1/5 to get the one that I want on the diagonal in row 2. And so notice it was possible for me to get the identity matrix on the left of the vertical line. And now that I have achieved that, the matrix that is to the right of the vertical line is my inverse matrix of A. So if I multiply this matrix by A, that product will yield the identity matrix. And that's how I find the inverse of a matrix. I get my zeros first and then the ones.